Okay, so we're having a look now at the next section about simultaneous equations. So these ones here are written in a sort of slightly unusual way, these ones, but imagine I have this line here, okay? Now, what does the line represent? Well, it's a set of coordinates that follow a rule. This is the rule of x plus y equals 5, imagine. This is another line. So on this line, which can be, anything, but I think we're going to pretend that this is 2x plus 1 here. These are all points where the x and the y value are related in such a way that they happen to fit on this line. And these straight lines, you know lots and lots of maths about that, hopefully by this point. So what does the intersection point represent? Okay, well, the intersection, and you're going to have many, many, many lines, curves, things like that intersecting each other. It represents where this rule and this rule are both followed. So it's a powerful thing because often if you have two different things, which could be formed from a model or some situation or anything, if you have them and you use them together, you're finding where both of these conditions are being followed at the same time, and it kind of tends to crack open the problem. So we're going to do some work with this. We might be interested in finding the algebraic answer, but that's what the previous chapter was about, wasn't it? Solving to find the algebraic answer. What we're probably going to do here a little bit more is think about the nature of if things do or don't intersect, or how many times they might intersect. So sketching and reasoning is a big part of the course with this. So first question we've got here is on the same axes to draw these graphs. Well, this is a straight line. If we put it in mx plus c form, which is minus 2x plus 3, this is very easy to draw. You can also use the table mode on your calculator if you want to very quickly find the values, or if you have more unfamiliar functions. Okay, so this is another one for you to check. Lots of learning to use your calculator in this chapter, yeah? We've got simultaneous equations, we've got solving polynomials, we've got entering functions as a table. So I'd encourage you to have a go at that. The quadratic, now you learned a lot about quadratics in the previous chapter. The quadratic and the straight line, we're going to draw them at the same time. We're not going to be overly focused on turning points and roots for this particular example. We're just gonna think about the sketch, okay? So use your graph to write down the solutions. So it says use your graph. So what we're meant to do here is we're meant to say that we're interested in these points here. These are solutions. So a quadratic and a linear together in this case are giving us two solutions at minus 1, 5 and 2, minus 1. Would we always get two solutions? No, we wouldn't. Imagine if I had a quadratic and a straight line like this. I might have no solutions. I might have one. Imagine that there's just one point where there's some sort of tangent. Okay, we're gonna talk about these all in a moment a little bit more, but it's not so easy as there's always two, there's always zero. Okay, so here are solutions, and really that point from before brings us to this part here. So what algebraic method that you may have learned in chapter 2 before could we have used if, just pretend if, we were not allowed to draw this, or we didn't want to go as far as solving it? What would we have done? And we did talk about this in the previous video. Well, what we would have done is we would have used the discriminant. So if I set them equal to each other, and get a 0 on one side, you have this new quadratic, which is x squared minus x minus 2. And this quadratic is not drawn. You don't see it here on the graph, but this is a powerful quadratic, because what this quadratic does is it tells you the nature, yeah? So it tells you how, tells you the nature of the intersection. Or even if there is any intersection, we don't need to draw it, but if we solve it, or we use, in this case, we're going to use the discriminant on it, it tells us things. So the a value is the coefficient of x squared, so that's a 1. Okay. The b value is the coefficient of x, which is minus 1. And the c value is the constant, which is sometimes just a number. Sometimes you'll see like an unknown constant as well, like k plus 2 or stuff, okay? So sometimes it's a bit more complicated, but here it's just a number. And if we put them into this discriminant thing that we talked about a little bit, we get a positive number. And what that means is it means that when you do your quadratic formula, okay, when you do your quadratic formula, which we don't need to do, you have something under the square root, right? You have the number 9. So you're adding on and you're taking away a number and then dividing when you get your solutions. In other words, there's a difference between them. So you will, if you solved this, which you don't need to do, you would get 2 solutions. So what's that all about? What's the point of that? Well, the point of that is it describes the fact that the 2 original things intersect each other twice. Okay, so there's quite a lot going on here. It's quite difficult the first time, but the quadratic and this straight line, their behavior to one another is found by this third function, which is a result of us solving them together. And doing the discriminant can tell us what's going on without us having to draw it and without us actually having to solve it. So notice it doesn't say what are the solutions, it just says, you know, how would we know if they intersected or not, basically. Okay. This only works, it's just worth saying here, this only works with quadratic functions. Okay, so if we had like a cubic, for example, that wouldn't be helpful for us. The same question here. I'd like you to have a go at pausing the video for yourself and trying these ones. Please don't obsess too much about roots and well, we don't need turning points anyway. Please don't obsess about that. Just feel free to use your calculator on this one to get your roots to draw. Draw them on the same axes. As accurate as you can. Maybe use the table mode on your calculator to help you out. The more accurate you draw that, the more it will help you with B. So I'd like you to look at your sketch, but then I'd like you to try an algebraic road and to show me that the lines never meet. And never meet, I'm going to say to you, tells you something about the discriminant, is the clue that I'm going to give you. So pause the video here. And if you've done that, on a sketch, they won't cross, but of course, it's sometimes quite hard to draw an accurate sketch. So it might be difficult for you to know that exactly this is the situation, you know? It might be difficult for you to know. Maybe they would cross depending on how accurately you drew it. But if we go down the discriminant road, so discriminant road, step 1, we set them equal to each other. Step 2, you get your quadratic equal to 0. Step 3, you write out your A, your B, your C values. Step 4, you put them into b squared minus 4ac. Always b squared minus 4ac? Yes, always b squared minus 4ac, please. You get minus 8. Now, so what? What does that mean? Well, again, let's go back to our quadratic formula. So imagine if the bit underneath the square root is a negative, like minus 8. What's going to happen? What's your calculator going to say to you when you do square root of minus 8? It's going to say to you, no real solutions. So this is some sort of intuition for you about why that means that there's no points of intersection. You can say, you know, math error, or it breaks maths or whatever, and all these sorts of things. But really what you're saying to me is with real numbers, we can't square root negatives. Therefore, a negative discriminant means that they don't intersect each other at all. So here is a nice summary. This is straight from the book, but I think it's excellent at sort of talking about quadratics. So and the discriminant. So if you have a positive, that means positive greater than 0. It means that we've got a situation where we have 2 solutions. It doesn't tell us where they are, but it tells us that there's 2. B squared minus 4ac means that we've got a situation maybe like a tangent. Look out for the word tangent and quadratics together. This is a favourite, okay, using b squared minus 4ac. And if b squared minus 4ac is negative, it means we have no real solutions. So a situation like this, well, can you see from the picture what should happen? This would be one solution. So this means that the b squared minus 4ac in this example should be equal to 0. This is just like a quick example. So there you go. I've used those numbers there. X squared minus 3x plus 4. The other line I think is just slightly off your screen. That's y equals x plus 3. Okay. If I set them equal to each other and I rearranged it and I drew this again, this third function in the background, you'd find something quite interesting. You'd find that it was like this. So this idea of sort of one real solution is a little bit like saying a repeated root. Okay, it's the same sort of thing going on here, really. So we're going to do a word example and then a your turn, and then you're going to practice this idea of the discriminant a little bit. So here we go. The line with equation y equals 2x plus 1 meets the curve with equation so on at one point. At one point is our key phrase here, okay? So I can see that it's a quadratic. I'm told that it's 1 point. So the first thing I'm going to do is I'm going to write down my condition. It's not enough for me just to write this. I should write the condition, which is equals to 0 in this case. Now, notice that this is a question that we couldn't really do before with GCSE maths. This is new. We've learned something new, and we can apply it to this more difficult situation. I'm going to start by taking my 2x plus 1. When it's y equals and sort of another y equals, really, I can just set these things equal to each other, okay? So, do I want to just do it that way? No, I think I'm going to, because it's equals 0, just thinking about this. So I think what I'm going to do is I'm going to sub into this y value here, okay? So let me write out the long quadratic, which is kx squared plus 2. The y is the thing I'm substituting into, so I'm going to give myself some space to work, plus k minus 2 equals 0. Now the substitution is that y is 2x plus 1, so that just goes in there. So it's now kx squared plus 4x plus 2 plus k minus 2, 0. The 2 and the minus 2 happen to cancel very nicely. Let's tidy this. Well, it's sort of tidied itself up now. This is the a value. List your a values. So a is k. It's allowed to be in terms of like a letter. B is positive 4. The positive belongs to the 4, so 4. C is just k here. So what we're going to do now is we're going to sub these in to our condition, and it should let us find the value of k. So b squared, if you want a little bit of advice as well, if you want to kind of always get the right answer, you just do this first. This is just me writing b squared minus 4ac with brackets instead of everything. Useful when you use calculator stuff later. So b is a 4, a and c, these are both k here, so you can't really go too wrong with that. So this becomes 16 minus 4k squared equals 0. If we get things to both sides, if we get that positive, that's going to be this. So k squared equals 4. K equals 2 or minus 2. Check the question. Given that k is a positive constant, explicitly cross out minus k. It's not possible. So there we go. K being 2 achieves this scenario. What can you then do? Well, a part B, let's just write this in. A part B might say, well, now since you've solved this problem, do the easier bit. So what do I mean by that? Well, there's two ways you can do this. Okay, so one way is we could sub k into the quadratic now, and we could say, so that's 2x squared plus 2y plus 2 minus 2, equals 0. We could do that, but if we want to save time, the clever thing to do is to recognize that we need to solve simultaneously again anyway. So we could, in fact, just go back to this line here, and we could write that in. So we could, a better way to do this would be to write in 2x squared plus 4x. The 2's cancel and stuff, so that's fine. Plus 2 equals 0. Divide every term by 2 because there's an equals to 0, so that's an easy step. You get x squared plus 2x plus 1 equals 0. And then if you try and factorize that, you get the x, you'd get x plus 1, right? So x is equal to minus 1. And if x is equal to minus 1, if you sub it back in this one here at the top, that should be what? Minus 2 plus 1, so minus 1. Notice that there was only one solution to this, which was the whole point of the question before, so that's a good sign. So the main part here is part A, okay? So part A, we use the discriminant. I'd really recommend state your condition out. solve them simultaneously, list your A, B, and C. Okay, get to your answer, check you read the question. Part B, if you're wondering how I skipped here straight away, well, it's because if you started everything from scratch, you'd just be repeating a step that you had already done in part A. So it's just a slightly more efficient way of doing it. It's time for you now to have a go then. Add this one here. So pause the video, have a go for yourself. We'll reveal it and we'll talk through the steps as well. So on this one, the condition of two real roots is the following. So we need this at the front because we need to see where it comes from. This is a show that question. If we are sort of just lazy with our inequality signs, there's a good chance we won't get the mark. You can see that from the mark scheme. CSO means correct solution only. So it's not just about writing this because this is in front of you, okay? It needs to be convincing. Now, this one, it was just a quadratic, right? It wasn't a quadratic and a line. So it's like we had one less step. But what we were meant to do still is this was our A value, this was our B value, and you had a more complicated C value. So 5 minus K was deliberately in a bracket there because that all was meant to be C. So B squared, yeah, that was your, that's where your 16 came from. Minus 4, A was a K, and then it was 5 minus K with this condition written out, okay? When you did that, you should then have been able to arrive at this one here. So notice that even if you couldn't do part A, you could do part B. It says find the set of possible values of K. Now, set and values tend to mean inequalities. So really this was saying to you, solve this inequality. You have a mode on your calculator to do this, to check, but we need to be able to do it without. So 1 and 4, they're called your critical values, okay? So that should have been hopefully nice and easy to get. You often get marks for choosing the right region. This is the outside region. So why is this? It's because when you sketch this, it looks like this. And you were looking for greater than 0. Okay? These parts that I've highlighted here are not connected. It means going off to the left, so less than 1. It means going off to the right, bigger than 4. Now, 90% of students, maybe not 90%, maybe 50% of students won't sketch this. But then you'll get incorrect inequalities. I see incorrect inequalities for this all the time, which in my opinion is inexcusable. Okay, it's throwing away marks. So a very, very quick sketch like this, just to help your reasoning and saying 1 and less, or less than 1, it's not actually, you're not allowed to use 1. And 4, so bigger than 4 is what's required. You can check in this case as well on the inequality mode. Yeah, the inequality mode on your calculator. Okay, so there really is no excuse not to get full marks on this bit, please. Okay, so you've seen 2 different examples there. We put a line and a quadratic together and then did the discriminant. And on this one here, we just have a quadratic on its own at the start. And we can also do the discriminant with that as well. So plenty of practice for the discriminant is well deserved. This is an exam paper favorite. Spotting it and using it or applying it is incredibly common, even in the full paper of the year 13 pure at the end. So make sure you get lots of practice of this one.